Hello,
Hello
and
Deepak.
welcome
Yeah.
everyone to another session in the DataHour series. We are thrilled to be here with you this evening for a session full of action-packed learning. I am Deepak Singh Bisht, part of the data science team at Analytics Vidya. For those who have joined us for the first time, a brief introduction to the DataHour sessions. The DataHour is a series of webinars conducted by the Analytics Vidya and led by the top industry experts. It is a fun way to understand the concepts of data science from the leading players in the data tech domain. And as the name suggests, it's 1 hour dedicated to data. We are hopeful that these sessions are going to be a great source of enrichment and value adding for our community members. Now, on to our session today, which is DCNN for machine RUL prediction using time series data. RUL is the remaining time or cycles that the machine is likely to operate without any failure. By estimating RUL, the operator can decide the frequency of scheduled maintenance and avoid unplanned downtime. In this DataHour, the speaker will explain the RUL estimation of a machine using sensor data, using realistic multivariate time series data for leveraging the power of deep neural networks in the hands-on. He will also focus on how you can build a DCNN, which is Deep Convolutional Neural Networks model for the prediction. I hope you're excited to attend this DataHour with us. So before we kick things off and I hand it over to our speaker, a quick recap of the housekeeping items. We are recording the session and the recording will be available on our YouTube channel. The link you can find in the chat section. Please use the QA section for asking any questions you might have during the session, and we will do our best to answer them as the DataHour progresses or towards the end. And lastly, we will share a feedback poll towards the end, and you all are requested to kindly fill that up before leaving the session. Now, on to our speaker. In this session of DataHour, we have Jidhu Mohan M with us. Jidhu Mohan M is currently working as a data scientist with IBM System Labs. He has been working as an integral part of corporate research division for more than a decade now, with expertise in multidisciplinary research fields like industrial AI, deep learning, machine learning, NLP, KG, predictive modeling, and time series forecasting, reinforcement learning, Internet of Things, and product engineering. He has built multiple products, MVPs, POVs, which were deployed and have generated new business avenues. He is a passionate researcher and has filed 4 patents as part of his research work. Over to you, Jidhu. The virtual stage is all yours.
Thanks for all joining this specific session. And what we will be looking into is the DCNN for machine RUL prediction. This is actually we will focus on machine RUL prediction using time series data and how we can actually do that, or how we can do a remaining useful life prediction of a specific machine using leveraging the techniques of deep learning. This is what we will focus. Next chart, please. Okay, yeah, I think Deepak already mentioned about me. So this is a short intro about myself. I'm working as a data scientist in IBM Labs. And prior to IBM, I was with corporate technology and research and Siemens. And before that, I was with technology and innovation with Bosch. So maybe we will not spend too much time on me. I know you guys are interested to listen to the topic. So let's go to the next chart quickly. So I will share the details, LinkedIn details also, and my GitHub profile details also, so that you can connect with me. And also for the hands-on, we will be able to use the code also. So today agenda is, first we will look into the 3 important things about this specific use case. What exactly is the problem statement? Why the specific problem statement is relevant in the industry, and how we can actually solve this specific problem statement. So what, why, and how, then we will more look into the specific use case itself and a little bit about the data and what kind of data set that we are going to use. And then to the time series forecasting, multivariate time series forecasting after that. And then the AI algorithm that we are going to use, a little bit about that. And then we will quickly move to the hands-on where you will be more excited to experience how this is really working. And in hands-on, we will be looking into maybe understanding the data, and then what kind of pre-processing that we are looking into here, and normalizations, and how we can prepare the data for DCNN, and how we can train the model, and definitely how we can do the inferencing, and also we will discuss on the results. Okay, so next chart, please. So first of all, what exactly is machine RUL? Remaining useful life is, as the name suggests, a specific machine. When in the operating time, the efficiency of that specific machine, because of the wear and tear and all, it is going to reduce. So what is the available time right now till this next service, or maybe till the next failure? That is what the remaining useful life that we are mentioning here. So, and specifically, you can actually state it as the remaining time a machine is likely to operate before it requires repair or replacement. So if you look into the right side, the graph here, you can see that on one axis you have time. So in this specific case, it will be number of cycles. It can be the years, or it can be months, or it can be days or hours, depending on the kind of machine that we are looking into. And on the y-axis, you have health of that specific machine. So as I told you, the health of a specific machine is going to reduce over a period of time. And eventually, that specific machine is going to fail because of some reason. It is applicable for a specific component in that specific machine also, or that complete machine itself. Take an example about an automotive, the gasoline car. Let's take an example. Okay, so it's going to fail. Before failing, it is better that we do the maintenance so that we are not in the trouble at that specific time when it is failing, right? So, but it will be great that if you know this remaining useful life of that specific machine so that you can plan your maintenance. So in this specific session, what we will be looking into a realistic time series data, and using the specific time series data, how we can actually identify the remaining useful life of that specific machine and how that will be useful. Next chart, please. So why the machine RUL is relevant? So you will come across many machines in your daily life, right? Or if you are a plant manager, definitely you will be looking into machines, or you will be taking help of machines along with your workforce. So it is very important that the availability of that specific machine is confirmed so that your business is actually running smoothly. If you are a plant operator, one of your machine is failing, then it's actually causing an impediment for your production, and the throughput is reduced so that your business is reduced. Take another example where you might have irritated with this particular machine failures, or the delays caused by this maintenances, untimely maintenances. So you are waiting in your for the next flight at your gate, and suddenly this particular red line is coming saying that flight is delayed. You are irritated, and you have to now plan more about your travel and how much time you are going to wait. You are anxious about that, all these things. And you know, like you, the airline company is also kind of frustrated because they are losing their reputation. They are there as overhead costs because of this particular delay is actually coming in on them. And, you know, it is actually calculated that millions of dollars is actually wasted because of this particular airline delays itself. So it will be great that if you are able to identify maybe this particular maintenance schedules well in advance so that we are not getting into trouble of the untimely maintenance. And you know, the negative impressions that is actually creating because of this is actually impacting a lot more than the money that you're spending at that time too, right? And but is it very easy to identify these particular faults? It is not actually, because this is a complex system what we are looking into, and a lot of components into that. And we cannot do a very frequent maintenance also, because these particular frequent maintenances are going to take a lot of dollars from your pocket if you are doing if you are going to the frequent maintenance, specifically maybe a flight or airline. Definitely we can do some checkpoint. There is checkpoint so that it is not getting it is not failing at any point of time. But at the same time, well in advance, if you are able to predict something like that, is something that we are looking into. Next chart, please. So how actually we can predict the machine RUL? There are multiple ways that we can do. So one such approach using the data is what we are looking into right now. That is using AI, how we can build a model using the run to failure data, and then how we can use this particular model for the predictions. That is RUL estimations. This is what we are looking into. So now let's understand what exactly is the run to failure data. So you can see in this particular graph here, the lifetime of that particular aircraft is actually here. Lifetime is actually the lifetime to the next immediate maintenance I'm mentioning here. So you can see the condition indicator value of this particular aircraft, that is the specific jet engine. Okay, somebody is asking what is RUL. I think I have mentioned this before. RUL is nothing but remaining useful life for specific machine. So for example, in this specific case, what you can see, these dark stars that we have here is the maintenance operation or some failures identified in that specific aircraft. So the indicator, the condition indicator, is actually an indicative value of the health of that specific machine, right? And on the x-axis, you have the number of cycles. So one cycle is the complete flight, that is takeoff to land into the next airport. That is the complete cycle that we are discussing here. So a red line actually shows that one specific such turbocharged jet engine, this is actually getting the health is actually coming down over a period of time, and finally we are here. Now the question is whether it is going to fail here. That is, this is the time period that we can actually look into till the next maintenance, or whether it is going to fail here itself. So, or maybe somewhere here, or maybe somewhere here, we can actually do something so that it is actually failing. We can identify this failure here. So this specific time duration from here to the failure, that is the how many number of cycles, that is the remaining useful life that we will be indicating here. So what we will be using is run to failure histories of this specific data set we are going to use. And we are using this particular data set, we are going to build a model so that we will be able to infer whether if given a this specific data, whether it is going to fail or not. So next chart, please. Now, as I told you, what we will be looking into is a turbofan jet engine in this specific session. The remaining useful life is nothing but the number of cycles which is remaining. That is the number of flights it is actually remaining till the next maintenance has to happen. So if you are able to identify maybe 24 cycles are remaining, we can do a proper planning for that particular maintenance. Maybe at that time, or maybe around 22 or 21, we can plan a maintenance so that we are properly maintaining, so it will not get maybe get into an untimely maintenance situation, which is not favorable. Now, the data set that we are going to use is turbofan engine degradation data set, which is from NASA. So I have given the links and all the links and the references in the GitHub page also, and the end of the specific PPT also, you will be able to get that. Now, what we will be doing here is this specific data set what we have is around is having 21 sensor information. So each data point is actually sensor information which is actually recorded. So as you know, sensor information is having the x-axis is the time and y-axis is that particular parameter. That means it is a time series information. Okay, so this is the information which is available to you about this 21 sensors. Definitely, the remaining useful life, which is actually identified by the expert with that specific conditions, is also provided there. Since it is an actual data and partly it is some part it is actually simulated also, you can see a real sense about how we can actually build a model for a real machine using this particular data set. Now, all these particular engines are of similar type. So this is one important thing then we have to consider when we are considering into remaining useful life, because these particular sensor informations that should be that we are recording should be similar. Definitely the machines that we are actually using also should be similar. Otherwise, it will unnecessarily complicate your model and you will not be able to get a good model so that you can a reliable estimation is not possible in this specific case. There is actually a huge challenge about the recording the specific data also. Maybe I will keep that specific challenges and all to the end of the session. Let's go to the next chart. So as I told you, the data consists of multiple sensor information. Sensor information can be the fuel flow or the speed, fan speed, or maybe the hydraulic related pressure information, or maybe temperature information, and all these things. As you know, we don't have to worry about what exactly each individual sensor information is and to build a specific model. So we will not go into much detail about this particular sensor information and how it is actually related to maybe a failure and related things. So another important thing is that there are multiple other approaches also for remaining useful life. That also maybe at the end we can actually, if we are finding some time, we can discuss on this also. Okay, so what you can see on the right side is some of the sensor information which is plotted. So you can see there is actually on the y-axis that specific sensor, detailed sensor values, and the x-axis is the cycles, which is actually also noted. So as you know, the remaining useful life will be reducing. That is the first data point will definitely have the highest of that specific data frame. I will talk in the data frame language because what we will be looking into a time series data, and a time series data means we are looking into a series of data points which is actually connected, right? Connected on the time axis. So we are considering a window of this particular data at a particular time, and then we are trying to find the RUL. So as I told you, the remaining useful life of right now will be maybe if it is 24 after maybe a couple of flights after that, it will definitely come to 22. If your model is good and your inference was actually good, definitely it will be going down. So what you will see is the number, the remaining useful life is a decreasing number, and the Y, which is your nothing but your target value that you try to predict. And the other values, you have sensor information. And apart from this particular sensor information, you have some setting values also. Setting value can be the kind of flight it processed. For example, it was the recording of this particular flight degradation. The aircraft engine degradation was recorded at the specific region or with some specific parameter. For example, the altitude can be one of the parameter. So at specific altitude it was running, and this was recorded, and related setting information. This can also be coming into settings. In this specific data, what you will have is the remaining useful life of around, I think, 300 or so, 200 to 300 flights is available, and we will be using that particular information here. Next chart, please. So, okay, so before going to multivariate time series, I'll just look into, okay, GitHub and PPT. I will be actually giving you these particular details. Okay. Okay, Ariel. Okay, I think LinkedIn information related. Okay, keep me posted about your questions. I will be looking into intermittently so that we can address some of these important questions then and there itself. Okay, now let's come into multivariate time series data. I told you that we are going to use the sensor information. So generally, let's say, for example, if you have done time series forecasting, you know that there will be a time series variable will be there, and you're trying to forecast something into the future. So what we will have here is remaining useful life, which we want to predict, and multiple sensor information that which is actually indicated here, so that we can actually do the prediction. So this is not only for one flight, that is for multiple flights it is there. That is multiple similar turbo jet engine data is actually available. So that is indicated in maybe from sample 1 to sample n. So these information, so which is there available for you. So each particular data set, a data sample out of this particular data will contain remaining useful life, which is actually decreasing from 200 maybe to 0. 0 means it is that failure happened at that particular time. So this is information what we are going to use. So in fact, you can actually think about the specific data, something like this in this particular 3D format, where in each papers you have the sensor multiple sensor information. Likewise, you have multiple, maybe 200-page notebooks, something like binded together, papers binded together. That is the data, the tensor that we are looking into here. Now, next chart. Okay, what level of time series data is available? I mean, minute or hourly. Okay, so as I indicated before, the x-axis, what we are looking into will be the cycle. That is each individual cycle that we are looking into. So one specific cycle, that is what will be available, individual cycle information. Maybe we will get into the data related information available that I have. I will show you that. I think you are more focused about one specific data point. We will definitely look into that. Okay. So DCNN, which is nothing but the deep convolution neural network, this is the model that we are going to build. And so there are multiple other approaches, again, apart from the DCNN, with which you can actually do the estimation, that is the modeling you can do. This is one such approach which actually works. Why DCNN actually works is, so here what we are trying to do is, there is a pattern in the sensor information that we want to connect to an RUL information, which is nothing but finally an integer value, right? So what is the number of cycles? So identifying patterns, definitely convolution neural network is good at that. So we can generally use it for, in this particular case, also multivariate time series analysis, we will be able to use. Definitely Lstm is also another option, but it is more tend to maybe overfitting many of the cases. And so here we will be looking into the DCNN 1D convolution that we will be looking into. Why 1D convolution? Definitely that also we will actually focus in our implementation. Okay, so on the right side, you can see again the chart which actually indicates the health. The red line is actually getting the health and remaining useful life. So assume that you are on the latest observation right now. What the available data points is there, what is available, the window before this particular data, that is, okay, what we will take here is a window of information. That means let's assume that we have a specific data set and we have the previous maybe 200 data points or maybe 500 data points. What we will be looking into is a specific window, and this window, the same timestamp for all the specific data that is available for us, and how we will be able to use that for our RUL estimation. This is what we will use, what we will do. So could you please compare the advantages of RN and CNN for this particular? Okay, so so let's say RN, LSTMs and CNNs, we will be able to use for the specific use case. And the advantage of CNN, as I indicated before, is actually we will be able to more identify this particular patterns and from this particular signals that we have, and a model which is actually using this, we will be able to build using convolution neural network. And convolution, as you know, the pattern identification it is good at, so it is good at this particular case. And LSTM, definitely, it is a multivariate time series, and LSTM goes together. So LSTM is also an option which we can actually experiment, which has actually give good results also. But we have to be very careful about overfitting in LSTM. So if you have used real data on using LSTM, a complex LSTM network, ground up, if you are building, definitely you might have faced this particular problem, that the overfitting related issues, which is actually prevalent in a LSTM network. But there are, if you're investing time on either of this, you'll actually get, and maybe a mix also actually works better. But here, what we are looking into, Dcnn, convolutional neural network, we'll be looking into. Okay, so next chart, please. So this is the GitHub link you have to go, so that we can go through the code, and quickly we will be able to look into this. So Deepak, can you navigate to the specific GitHub page? Okay, classical Ankit was asking, maybe can we apply ARIMA model in this? ARIMA model, there are variants of an ARIMA model, definitely for the multivariate time series, and definitely we can experiment with that. But the specific problem statement is very difficult to model using an ARIMA or a variant of an ARIMA model for multivariate series. Okay, you can search for Mohan-MJ in the GitHub, and then please navigate to the Dcnn time series RUL. So please. Okay, so maybe can you elaborate? I think Bala has asked about maybe change point analysis. Okay, so pioneer in the time series, I guess, change point analysis. What is the change point analysis in the specific problem that you're looking into? Can you elaborate on that? And I can try to focus on that too. Okay, so Deepak, can you navigate to this specific GitHub repo?
Yeah. Okay, just a second.
I can help you also. Can you go to browser and then search and that? You don't have to essentially copy this, I can tell you. Okay, so can you type there git Mohan-MJ? Okay, Mohan, MOHAN, hyphen, it's not forward slash, hyphen, minus.
Hello.
Hello. Yeah, hyphen. So not forward slash.
Hyphen. Okay.
Yeah. MJ hyphen space GitHub. Yeah, first one. Can you go to the repositories? Yeah. And DCNN time series RUL. Yeah, here you need to open two files. Okay. So first one is actually the main.py. Below that, you can open in a new tab. Actually, I want both of these together. Yeah. And turbo RUL IPYNB. Okay, so what I have here is a notebook, which is using the turbo class, which is available in the other file, main.py file. And okay, you can scroll when I tell you. Okay, please. Okay, so what we are doing here is we are importing that particular class and creating an object out of it. So the turbo is the object, and we have the specific data which is printed below. So you can see unit number, which is nothing but that specific data, the flight specific number, and time cycle, which is available. Time cycle is nothing but the timestamps this particular data is collected. Definitely the settings are the settings information, which is actually I was telling you, and S1 to S21 are the data, sensor data, which is actually available. So you can see multiple unit numbers will be available on this particular data. For example, let's say you look into the unique unit numbers, turbo dot train, and you select the unit numbers, and unique, you will be able to see around 100 plus data, the unit numbers, which is actually available. So, okay, now what you can do is you can scroll down, Deepak, a little bit. Okay, next thing what we are doing here is definitely we will go to the in detail on the other code also, main code also. But before that, let's look into the data a bit. Turbo plot is actually plotting this particular data set. You can see S1, it is actually not 520, it is not varying for multiple signals itself. So as you know, if there is no variation which is actually coming from a specific signal, you cannot actually use this particular data for the model, right? There is no predictability using this particular sensor value. So which are sensors which you feel that it is not important in this particular case, definitely you can skip this particular signals from your model training, the data frame that you're making. And so that is why we are actually visualizing this particular data. Definitely not only visualizing, we have to go a little bit in depth into this particular data itself, so that a proper data frame for training and Dcnn is actually available for you. Please scroll down. So I have multiple data sets, and the signal data set, which is actually printed here. You can see that there is a trend in many of these particular signals, which is actually giving you that there are some variations happening that is identifiable on the sensor data. Definitely a complex pattern which need to be modeled. And then you can use this particular information for building your model. Okay, so right side, there are some data. It is not uniform for all sensors, but definitely you can generally see the trend that towards the end of that particular that machine. We cannot say that we can say that it is, since it is getting maintained. So till when it is nearing the maintenance, there is variations which is actually coming on the signal, which is definitely identifiable by a neural network. Okay, please scroll down, Deepak. Okay, you can see some of the data, the signals which may not be usable. Definitely, I'm plotting few of the signals here. From the complete flight data, I'm just taking only a sample out of it. You can in-depth look into all this particular data. Then you can come to a conclusion whether that is usable or not. Yeah, but yeah, in general, this is the trend. Please scroll down. Please scroll down again. Yeah. Okay, these are again all the sensor. Each sensor, different flights, it is actually getting plotted. Yeah. Different flights means it is not one cycle of you have to. So in the machine life cycle, it is like a life cycle of that specific machine itself. This is what I'm indicating to. Please scroll down. Yeah. You can see now the frequency, the RUL frequency. So RUL frequency is also important. You can see that the training data set, which is actually plotted the first, you can see multiple the training the RUL frequency which is available, and also you can see the training frequency of the which is the bar chart of the training frequency for the test. Also, there are some questions. How can we build a health indicator? Okay, so if we are able to identify RUL itself directly, we don't have to build a health indicator. Definitely, there are methods which is actually available to identify health indicator. For example, if you are able to identify, let's say, you can see a trend of exponential decay on some of the sensor values. If you work on mathematical methods, definitely you will be able to convert that to a health indicator derived from all this particular sensor information. There are a lot of works which is actually done on this particular area also. If you are really interested on this, serious about this, definitely try to look into that too. Okay, again, Bala is asking, can we use this change point analysis since the data is change point analysis? I didn't get that change point analysis. What you are mentioning, maybe if you are elaborating a little bit, that actually will be great. Definitely change, seeing some of the time series data, the change points are important. Then we can use that change points to derive maybe better data frames. That is something that we can do. But in this particular context, I'm not able to get. I think, yeah, there is a time series window. Okay, yeah. I think Bala is mentioning about there is a question, a detailed description about the change point Bala has mentioned. So what you're mentioning about how we can actually use this changes, the percentage of the changes, how we will be able to, yes, we can definitely derive this particular information also, and using this particular data. And there are a lot of papers, by the way. This is actually a kind of a golden data set for multivariate time series, and a lot of publications on this in this particular area. Okay, so can you go, Deepak, can you go to the second code, the next tab? No, not here. The second tab that you have opened. Yeah, exactly. So can you, yeah, slightly, can you zoom in a bit? Control ++ or Command Shift+. Yeah, that's fine. That's fine. Pretty fine. Okay. So first, you can see the importing libraries. Pandas, definitely NumPy and Matplotlib, all these things we are importing, and also pickle for dumping the data into the pickle file, and also the scikit-learn metrics. We are using our square score and mean squared error value. For that, we are importing this particular libraries. And then what we are doing is, can you scroll down a bit? Yeah. So we have this for building the convolution neural network. We have these particular imports. So you can see that con1d is used and max pooling 1d is actually used here. Maybe I will explain why this particular 1d convolution is used. And before that, let's go a little bit into the data also. Yes, can you scroll down? Okay. Class turbo. So I have a class here, which is indicating which has all the codes for the data manipulation and also the predictions and model building and prediction. So that is what is available here. So in the initialization, what we are doing is we have the data set. We are defining the column names for this particular data set and also reading the data. So you can see I have defined one more function, which is actually reads the data, which is calling along directly in the init itself. So in the reading itself, what we are doing is, can you scroll down a bit more? So what we are doing is, we are also appending the REL information, because if you see the data set, raw data set, I think John is asking about this particular notebook. Definitely it is available there. It is available in the kit. So please go ahead and clone the repo or fork it. Yeah. So it's okay. The train information. So the data set, if you look into the RUL information of the train, is available as a separate file. So you have to take that also and merge that along with this particular data. So that is why this add RUL is being used. And please scroll down a bit. Okay, a bit more. I'm not going into each line, but that is not the scope of this particular session. So plot sensor. So you have seen how we are plotting this particular sensor data. So this matplot lib we are using, and then using the pyplot, we are actually plotting all this particular the sensor data. Please scroll down. Okay. So again, a little bit scroll down. So this particular plot function is using, yeah, that's fine. That's fine. Yeah. So evaluate is actually to evaluate evaluation metrics. By the way, evaluation metrics for a multivariate time series is not only maybe RMSE or the R-square value, but for time being, we are actually considering these particular values. But there are other parameters also we will actually consider. Mean absolute percentage error related information we'll look into, and also the learnable, how much it is trained, learned related information, the sensitivity analysis, and all we will do afterwards. But yeah, this is something that as a first step, you can actually look into R-square value and the RMSE value. So I'm also building the generalized linear model also here using SnapML. SnapML is actually a very good library which you can use for quick linear models and also for the random forest models. It is very much optimized for multiple architecture. So please feel free to explore that also. So I have used a SnapML linear regression model to have a reference about this particular the prediction. Definitely, you should go ahead with the ARIMA models or on the multivariate, so that you can actually get that reference values also. Please scroll down. I'm not going again into this is actually fitting, and you will be quite aware about these particular steps. Okay, please pause there. Okay, can you scroll up a little bit? Yeah, add operating condition. Now, what we are doing is in the data set, you can see the setting value. So we are going to use this particular setting value, setting 1, 2, and 3. And then what we are going to do is we use this particular information so that with reference to this, we are going to normalize the data. General way is actually we normalize this particular data with the standard normalization methods itself. But what we specifically do here is with reference to the settings we try to normalize. This is important on multivariate, this kind of problem statement, that there is some reference, there is some operating conditions which is actually varying, or something on the same machines itself we are saying. So there are something varies. Definitely we have to normalize as per that particular values which is available. So try to build something with that reference value. Otherwise, what will happen is at the end of the model building, it will not be able to converge to a good point. So then you may have to come back and then do some experiment something. So if you have tried to do something on this lines in the initial time itself, it actually will be great. Okay, so what can you scroll a bit? Okay. Condition scalar. So this is the implementation of the standard scalar using this particular settings information which I have mentioned before. What we are doing is we are filtering out with the same settings values, all the kind of flights we are actually filtering out, and trying to normalize the values using the standard scalar itself, but with reference to that particular setting value. So you can see there are multiple setting value combinations is available, and with that we are actually doing the condition scalar. Okay. Now, can you scroll down? Yeah. Next is actually exponential smoothing. As you know, the time series data generally comes with a lot of noise. So these high frequency noises may not be useful that much for your predictions. So what you generally do is try to do an exponential smoothing. And yeah, this also, the smoothing, also if you are looking into it, it itself can be on another session, because there are different smoothing techniques that we can look into, and what is the what should we look into so that we are not losing out any information which actually contribute to the prediction, right? So that is very much important. So here we have an exponential smoothing implemented, which actually takes care of the high frequency noise. And please scroll down. Yeah, next what we have here is generate the training data. So in the training data, as I told you, what we definitely we should have a starting point and end point, and of this particular, from this particular time series data that we have, and we should be able to use this particular starting point, end point, and slide it over the complete life cycle, that is from start to end of that particular flight, that is from the highest value of the RUL to the lowest value, and to all the sensor values, and use each particular data frames for our convolution. That is what we are going to do here. So the first step is actually to get this particular window with some start value and stop value. Please scroll down. The sequence length what we have to select accordingly. So depending on the sequence length, this particular window actually varies. By the way, sequence length is also another hyperparameter which you have to tune. Generate data wrapper. So next what we are going to do is slide this particular window over the complete data set of that specific flight, and then generate multiple data frames, keep it, take the next flight information, that is the next unit, that is from start of that particular life cycle of the highest value of the RU to the lowest, and then slide again, take that information and do this for all the data. By the way, you should be very careful about shuffling about the data on this data, because this is a time series data. You should not actually go ahead and mess up with by shuffling this data points here and there. Now, please scroll down. And likewise, you have to generate on the labels too. Labels is pretty simple, because you are you have the RUL values. What you have to maybe take is when it is failing from that, and right now what is the value, the difference you have to take, that is the RUL value, and then you have to just give it as a Y. Okay, and you have a generate label wrapper also, which is doing that for all the windows that we are taking. Please scroll down. Okay, same thing we have to do it for test data also. The data generator you have to implement, but it's a bit slightly different, because what what we have on the train and test, the data frames that what we have, we are creating is slightly different. So maybe a few lines of code is here and there, it is different. Maybe you can go through that directly. Please scroll down. So next is building this particular model. So we are first of all defining the parameters. So that is input shape and the kernel size and dropout and all this particular information and the kind of activation that we are going to use and all this. And batch normalization, we are going to do all these things we are going to do. Now, I'm using what I have done here is initially there is actually a convolution neural network, a convolution layer, which is actually, well, you can say x equal to the conv1d. By the way, why conv1d? Have you thought about why conv1d? Generally, multivariate time series, will you go with convolution 1D convolution? The reason being, we don't want to mess up that particular data. So assume that, let's say, if you are going with the 2D convolution, if I give the data frame in a different order, that is the columns are slightly different, since convolution is actually taking care of the patterns. And so if both the movements is actually there, then you can actually look into, you can focus on the conv1d mainly, because the other one, if you change the column names and all, it will actually the learning will have the problem if you are using the convolution. So that is why the conv1d that we are using. By the way, we can actually use a conv2d also, but it is more complicated than this. But yeah, feel free to experiment with that also if you have some better maybe results from, then please try to share that information too. Please scroll down. And again, not going into each individual steps. Again, what I have defined is 2 convolution layers and then a dense layer and then a few convolution layers and then dense layer. So that is complete. And the model compile I have given ReLU. Okay, the last I have given ReLU because what we need is definitely that it's a kind the real value that we have to get. That is why we have used ReLU, and mean squared error we have used, and all the Adam optimizer that we have used, and all. By the way, you can also experiment with multiple tuning this particular with all this particular multivariate for this particular multivariate. There are a lot of opportunity for tuning on this particular implementation. Now you are fitting this particular model and the history, you will be able to see the fitted values. So just for the plotting purpose that I have done this. Now model evaluation, again, we are looking into this couple of values, R-square value and also the RMSE value, so that we will have an idea about how your model actually stands at this point of time. Okay, we can go to the notebook. That is the previous tab that we have opened, the previous code that we were opening, just this particular left side, the tab itself. Yeah. So please scroll down. Okay. So this is again just into what exactly the shape of the prepare the data and the Dcnn, and then we are training this particular model for 30 epochs, and we are building this particular model. Okay, please scroll down. This is how the training looks like, and it is actually reducing. And I'm not saying it is a kind of a perfect model, which actually there are, by the way, better implementation you can actually make using this particular the approach itself. You have to maybe Bayesian optimizer, and maybe you use kind of optimization on the optimizer for selecting the hyperparameters, and you will be able to get a better result out of it. So please try to experiment that, and if you need some help, please feel free to ping me on LinkedIn also. So model summary. Okay, can you scroll down? Okay. So this is a model summary. Again, I'm not going in depth into each model, the convolution layer related things and all. Maybe we'll spend some time for the question answers also. So if you have some specific questions on this particular model and all, we can actually discuss. But it's the convolution layer. You can see the first convolution block 0, you can see, and after that, each block is having a conv layer and the batch normalization activation and definitely the dropout at the end and a max pooling. So like this, we are repeating a couple of times, and then we have a fully connected layer at the end. I mean, a couple of fully connected layers at the end, so that we have, maybe scroll down a bit. Okay. Yeah, FC1 is the first layer, and then we have FC2, which is at this layer, and you have, can you scroll down a bit? Yeah, this is how it actually it looks. So around 89% accuracy for the training that we are getting, and 80%. And again, on a time series, this number is the accuracy number. Along with that, we actually have to look into multiple other factors also to see that how the reliability of this particular model, all these things. I am not going in depth into that because that will become another session itself. So this is where we can also try implementing that, and definitely please feel free to ping me for any of the any help that you need. By the way, this notebook will run for sure, and if you are facing some issue, definitely I will help you on that. And also the main file also you can use any of the IDE, and then just requirement of text file you can use to set up the environment. It should run without any problem. So how okay, so once you have this, so how we can actually calculate your, maybe Rajiv was asking about how we have calculated the RUL. If you are just looking into inferencing on inferencing, so we can use the same function, what I have written in the main file itself, to create, maybe let's say take a specific data frame out of this particular data set. And then you can create the data frame which is required for this model and pass on to this model. The predict will be able to give you the prediction directly. So I have written that also. It should be in the model underscore eval. It is inside. So individual prediction values for the test and all, it is actually there. It is coming out. Maybe I'm not printed in the notebook. If I had access, then we would have actually gone into the code and I have shown that directly. Okay, yeah, Bala, I have actually used it for a linear regression, not for to maybe use that specific model, but just to explore that. Just it is once the data is there, we try out with some models so that we get an indicative some figure about this particular data. So that is why I have used that as not for any kind of a prediction purpose or anything. That is just for our reference. So yeah, you're right. Maybe since it is a time series signal, not be a good option to go with any of the linear regression, which is there in between the code. There is a small implementation on that. It may not be a good option to go with that. I definitely agree on that. So please post your questions. So we try to interact, maybe in rest, maybe 5 minutes more or maybe 10 minutes, depending on the questions. And then we can actually close this particular session. Definitely, we can look into some of the, you can maybe consider with the singular spectrum analysis. Spectrum, I'm, okay, is that a question or maybe answer to change the question? Okay, can be used multi-layer persistent bus. First of all, near load serialization and the lags when decide is constantly invariance or population. Otherwise, get into wrong analysis and wrong algorithm selection that way. Yeah, definitely. The MLP is also another option, but what I can see is, you try with maybe MLP if it is getting without overfitting. Yeah, I'll be interesting to see that particular model too. Okay, Swami Nathan, can you bit elaborate on tabular data? Tabular data means, I can consider this as maybe a tabular data. Yeah, this is a tabular data, right? It is possible, but depends on that particular context. Definitely you can use, for example, NLP, you can use this, right? It is similar to this itself. So convolutional neural network. So convolution neural network we can use in multiple instances, and it's quite strong in that also. So if you want reliable models for production ready models, I'm not saying this is a completely tuned production ready model or anything. This is actually a reference playground where you can actually try to build more on top of this so that it is more production ready. Okay, I don't have an option to unmute you, but please feel free to ping me in LinkedIn, and we can talk in detail on this. Okay, if that option is available to unmuting, please do. We can have a short chat now also. Okay, so Roya, I think Roy has asked a question, when to use LSTM and when to use CNN. So definitely it is completely depends on the data and how it actually works for you. But if there is time dependencies we want to capture, we try to use LSTM a lot, and then convolution neural network we use when we definitely time dependencies we will, since it is a pattern anyway, time dependency is also pattern, we will be able to use CNN also here. And but it is a design choice you have to take at any point of time. I don't have a blanket answer for the specific question when exactly to use. What I have seen is that some of the cases LSTM actually works well, and but with more towards tending to overfit also. But CNN, if it is working well, it actually gives a better model. Swami, we can use for CNN for image data. The idea about using a image or CNN on an image data is actually we are identifying some pattern. So I'm trying to identify that pattern, and then the fully connected layer is to be capturing this connection between this particular pattern for a specific object, or maybe depending on the kind of problem statement that you are looking into, but object detection, then that is what we are doing. But say wherever the patterns are existing, we will be able to use CNN, deep convolution neural network, we will be able to use. And if you build a good architecture, definitely that pattern you will be able to capture. Definitely you should have an understanding about the pattern that you're going to look into, and then you will have better accuracy for the specific model. Okay, so a lot of questions. Yeah. As I told you, another analysis, different types of analysis also there for the specific problem statement. What I can say is different methodologies exist. This is the flight or machine diagnostics is existing from long before. A lot of numerical techniques actually exist and works very well also. I'm not saying that and again, I'm not a fan of completely building end-to-end solution with neural networks also. There are some specific area we can actually use the classical techniques and combine it with neural network. If we have, LSTM. Okay, see, in some of the why LSTM exists and why if you have CNN, this because LSTM time dependency capturing is very good. So if you see some of the problem statement which cannot be solved with CNN, it actually gets solved better with LSTM. So, but it depends on the data. And please feel free to maybe experiment with LSTM also here. Okay, and post me result. I have the results for the LSTM too, but I just want to focus more on the a CNN here. That's why deep convolutional neural network here. That's why I have actually done with this. But yeah, you can definitely use with LSTM too. Okay, any other question? Data. Can you maybe discrete time series? Time series is always continuous because the question is actually the use case dealt with the continuous time series data and what if the discrete time series data. So because it is, we call it as time series because there is dependency with respect to time. So with the variation, one axis of variation is actually values varying as with the time. So that is so that dependency is actually there. So discrete time series. Okay, so Samita, then what I suggest is definitely I'll be interested to discuss with you more on this also. Please feel free to ping me on LinkedIn and definitely we'll be able to catch up and then we can discuss. Okay. I think same thing with the Balasubramanian also, but yeah, your questions, some of the questions are very, very important and valid. I like the questions also. Please feel free to ping me. Okay, Roy, why do we have multiple layers of CNN? So CNN, I think there are some CNN sessions also, which is there as part of this series. CNN, one specific layer of CNN definitely captures some of the patterns, but complex patterns can be captured with the multiple layers. That's a thing. I think we have already overshooted with the time. Okay, 60 to 80 minutes, I think. Yeah, that's fine. Now, I will take up maybe a couple of more questions and then we can go ahead with closure. Have you used this model to try on digital twin to the aircraft industries? Yeah, digital twin is not, yeah, I have not used it. What I can see is definitely this is something that can be used for enabling a digital twin in an aircraft industry, on an aircraft, definitely. Yeah, if you have some ideas or something, definitely we can work on this. I will be happy to help you on that. Okay, what is this particular? So in NASA data set, there's one of the question is what is the sensor feature means S3? So in NASA has published two data sets. One of the data set, it is anomalized data. We will not get to know what exactly each sensor means, but they have also one more data where these particular detailed information. I have also pasted a snapshot of this sensor information there, and you can actually use that. So about this particular S3, since it is an anomalized data, I don't know exactly what the specific S3. So that is not out there in the metadata of this particular download. Next question, I think we will close with this question. What I am series data have continuous scan machine. Whenever it is in usage, the time series data is good. Yeah, definitely that can be actually done. Yeah, the scanning, it's these kind of scanning machines that is intermittently is being used. So what we will do is the ideal time we will consider. It can be considered only the operating time we will actually take. We can do it, definitely we can do it. Only thing is that the data frame when you are actually creating, right? So you have to keep an eye on the data frame. So that is a tricky part also in multivariate time series, that many of the time we feel that it is actually working, and but in reality, we might have done some silly mistake on the data, and it is not really training also. You will see this. Okay, and ensemble, yeah, definitely ensemble ML for this difficult ML methods. You can try, experiment, and then we can discuss on this end also. Okay, I think Deepak, we had a nice session. Yeah.
Yeah. Thanks. Thanks a lot, Jidhu. It was on behalf of Analytical Vidya, I would like to thank you and for your time and for delivering such a wonderful session.
I'm sure our audience found it insightful, and hopefully we can conduct more such sessions with you in the future. It's
I'll be happy to do.
already 9:50. Like we have to wrap it up now.
Yeah, definitely. So thanks. Thank you very much to all who has joined the session, and also thanks to Analytics Vidya. And all these details should be, I think, available. So links are already with you. If you are missing anything, definitely feel free to connect with me and LinkedIn. I'll definitely happy to help you. Okay. And
links are in the chat section.
Okay,
guys, you can access from there.
Okay, then thank you very much. And nice to meet you, and nice to discuss with you. And Saumyadan and Bala, definitely I am interested to discuss with you. Please ping me in. I think we are not able to discuss all the questions in detail from your side because of the time limitation. Okay, thanks to all. Bye-bye for now.
Thank you so much. Bye.